Alright, so right now we're going to take a look at one of the free response questions you were working on from the 2011 exam. It was on the very back side of the packet you had. And we are looking at polar coordinates again, and we are given the equation r at theta is equal to 3 theta plus sine theta. 3 theta plus sine of theta. And letter A asks us to find the area in the second quadrant enclosed by the coordinate axis and the graph of R. So I would recommend taking this and graphing it so you can see exactly what is in the second quadrant. So make sure your calculator is in polar, and then draw a graph of that, and then mess with your window until it looks something like this. That is what the graph looks like. I can even zoom out a little bit more. It makes a spiral, just like that. You can take a look at the numbers for the window if you like. Help you out a little bit there. You don't have to look at the graph on the right. That's something this program does for me. It's kind of nifty. But we want the second quadrant, so we want everything in here. And so you have to start thinking, alright, we're going to start here and go all the way to here. So my radius is going to start here, and then it's going to go here, and then it's going to go here, all the way until we get to the second point. So what angle values bring the graph here, and what angle values bring the graph here? I know straight up is pi over 2, and I know straight over to the left here is pi, so that's a good place to start. That is not necessarily the theta values that will get you there. That depends on your equations and how fast the graph is drawn. But it's a good place to start if nothing else. And so what you'll want to do is, once you have a good graph, you'll want to trace that value right there, plug in pi over 2. If your cursor, your dot, is in fact right there, then you're good to go. If it's not, you'll have to keep checking. And then you want to check the other endpoint over here. Is that actually at pi? Go to trace, plug in pi, and make sure that you end up here. Thankfully, this one doesn't have any tricky business going on. That is at pi, and this one over here is at pi over 2. That gives us our limits for finding this integral. So let's go back so we can write some things down. This is going to be an integral, and we now have our limits from pi over 2 all the way to pi. And so we just have to remember the formula for taking the area of a polar graph. It is 1/2 times r squared d theta. So in this case, we're going to have 1/2 the integral from pi over 2 to pi of 3 theta plus sine theta squared d theta. This is a calculator portion of the test, so you just plug that into your calculator. No need to do that by hand, and you should get 47.513 approximately. Make sure your 3 decimal places are correct. That's all letter A takes. Letter B. Letter B asks us for theta over 2 to theta to pi, there is one point on the polar curve R with x coordinate equaling -3. Alright, let me go see what they're talking about. So there's one point where the x coordinate is equal to 3. So if I go over here to 3, indeed, there is one point right there. And it looks like they say, find the angle theta that corresponds to point P, find the y-coordinate, show the work that leads to your answer. So they want the theta, the angle that gets us there. So there's the radius. They want the angle theta, and they want the y-coordinate, since we already have the x-coordinate. Alright, that's going to take a little bit of algebra. So what we first do is we want the x-coordinate to equal -3, so we do have to remember that x equals r times cosine of theta. We have to have that equation memorized. We want x to be -3. We know that r is 3 theta plus sine theta times cosine theta. And we just have to figure out what theta value will give us -3. That looks like an algebraic nightmare, so you do not want to do that by hand. You want to plug this into your calculator into y1, and you want to plug this into y2 and figure out where they intersect. Now you must make sure that on your calculator that you are not in polar. This is not a polar equation. This is a rectangular, this is a function, so go into mode, go back to, I believe it is function, then plug those into y1 and y2 and see where they intersect. And you should get a value, it'll tell you x, but in this case it is theta, of 2.0169. Approximately. It has a few more decimal places, but that is where they intersect. Yes, your calculator will tell you that is an x value, because when you're in function notation you use x's, but we do know that it's actually a theta. Cross that out. Alright, they also wanted a y-coordinate, so you do again have to remember that y equals r sine theta. Well, y equals, we know what r is 3 theta plus sine theta times cosine of theta. Oops, I wrote that wrong, didn't I? It is r sine theta, not cosine. There we go. Well, we know what theta is. Theta is 2.0169. So all we have to do is plug that in. I would recommend take this, plug it into y, what are we on, y3 by now maybe? Turn the other ones off, and then go to table and plug that in. Make sure again you're not in polar. This is not a polar equation. This is a rectangular equation. So you're going to have x's here instead of thetas when you plug it into your calculator. And then you'll plug in 2.0169 and you should get y equals 6.272. So you'll have to do that on your calculator. It's not too hard to do. The next one is a little harder. It at least takes different type of thinking. So C. C asks, a particle is traveling along the polar curve, so its position is x at t, comma, y at t, okay, and such that d theta dt equals 2, d theta dt equals 2, find dy dt, at the instant that theta equals 2 pi over 3. So when theta equals 2 pi over 3. And interpret the meaning of your answer in the context of the problem. Alrighty, interesting there. So we need to find dy dt. Let's see, we have an equation for y already. Y equals, it's right here, 3 theta plus sine theta times sine of theta. Now, there's an issue here. I'm going to write this out this way. We want the derivative of y with respect to t, where y is 3 theta plus sine theta times sine theta. And hopefully you can see the issue here. The main issue is that our variable down here does not match our variables over here. And so when we do that, we have to realize the chain rule is happening. So the derivative of y with respect to t, when we take that derivative, we're going to take the derivative of y, and y is in terms of theta, so we first have to take the derivative with respect to theta, but then we have to multiply by the derivative of theta with respect to the variable we actually want, which is t. That's the chain rule there, technically. Thankfully, they give us d theta dt right there. So that's nice. So whatever we get here, we're going to multiply by 2. Just like that. And dy d theta, taking the derivative of this, you don't actually have to do that by hand because you want the derivative at theta. So you can just plug that into your calculator. Take the derivative of this one, and at the point 2 pi over 3, plug that into your calculator, and you will get your answer. That's all you have to do there. I haven't actually done that to get the number. I think I might still have the answer pulled up. Oh, no I don't. Sorry. You'll have to do that in the calculator to get your answer. And if you really need me to check it for you, we can. But you just plug that into the calculator, and it should give you a decimal. Don't forget to multiply by 2 at the end. That would be a sad, sad mistake. I hope that helps.